Hello, grade 12. Again, Loci. We are on Loci. I'm doing an example from a textbook. It is this textbook, Mind Action, Engineering, Graphics and Design, grade 12. It is this textbook. This was a sample. It was not for sale. I'm not sure whether it is still available or whatever. It is task 25 on page 182. I saw this one as one that almost combined most of the cam, as the cam, the different types of cam profiles. Task says a plate cam rotates at a constant velocity in a clockwise direction, imparting, giving us the following motion to a wedge-ended follower which reciprocates. Which reciprocates along a vertical center line. Can reciprocate this way or that way. Vertical, horizontal. Sometimes it will move horizontal. This one is vertical. Center line that passes through the center of the camshaft. It passes through the center of the camshaft. The motion of the follower. There is the motion, how the follower is going to move. 1, 2, 3, 4. That will be the motion of the follower. Now, this is the information that we want to start with. It says the minimum distance from the camshaft center to the cam profile is 18 millimeter, where the profile will start. The cam rotates on a 20 millimeter camshaft. The follower is 8 millimeter wide and 68 millimeters long. Let's interpret this information that we have here. This is vital. This is where we start. Forget first about the profile but you can read the profile so that you know where to place your center lines and how the height of your cam profile, how will it look like. It says over the first 120 over 120 degrees, the follower rises to a height of 40 millimeters. So you have a height of about 40 millimeters. The follower rises with uniform motion to a total height. So total height is 65. It's growing now from 40 to 65. The follower then falls. You'll have that height of 65, which is the total height. And then the follower falls over the next 60 degrees with uniform motion. The follower returns to its original position. So it will move a total height of 65 millimeters. Total height of 65 millimeters. Let's do it. We will start with the center line. Every time I'm considering my center. With me, you bear with me, I'm also considering my center, just making sure that you will be able to see everything that I'm drawing here. Good, let's see. Here is my center. Start probably here. I'm not looking at the paper. With me it's different than you. I'm looking at my cam angle and how much space will my cam accommodate, so that you are able to see everything that I'll be drawing here. Now let's do that. From here it's center, there is another center goes there. We'll be interpreting the information. I'll keep on bringing on the textbook here. Said this is the most important part of first starting out with our drawing. The minimum distance. The minimum distance from the camshaft center to the cam profile is 18 millimeter. 18 millimeter. The minimum, the lowest point from the camshaft center. The center will be here. They say it is 18 millimeter. Now Here is my 18 millimeter. My 18 millimeter. Use my ruler there. That is my 18 millimeter. Minimum distance is 18 millimeter. I don't make it solid. That is the minimum distance of the cam follower. Now, back to the question. The minimum distance from the cam shaft center to the cam profile. Where the profile will start. We'll start drawing the profile. I'll show you what the profile is 18 millimeters. The cam rotates on a 20 millimeter cam shaft. 20 millimeter diameter. Our cam shaft is 20 millimeters in diameter, which means it has a radius of 10. Cam shaft is 20 millimeters in diameter, which simply means it has got a radius of 10. There it is, a radius of 10. This is the real deal. This is our cam shaft. The red shaft there at the center. So you would like to section this one, because this is the cam shaft. It has been cut so that you are able. I hope everyone has seen a cam shaft before. Ask your educator to show it to you if he can. It does not have it, his or her workshop. Google and see how a cam shaft is. It's a shaft. It has been cut. It has got cam lobes and so on. It has been cut here. This is the shaft, cam shaft diameter. That will be the minimum distance from the cam shaft center to the lowest point of the cam profile. And then it tells us that the minimum, the cam rotates on a 20 millimeter cam shaft. We've drawn that. The follower is 8 millimeters wide and 68 millimeters long. The follower 8 millimeters wide. So this is what I would want to do when I'm drawing my follower. It's 8 millimeters wide. Width that gives me 4. There is my 4. There is 8. Just want to be 100% sure here. 4. From there is 4 millimeters. Very faintly. 4. Very faintly, trying to get to my follower. And then it is a, what type of a follower? It is a wedge ended follower. It is a wedge, like a pencil. It's just like that. It's a wedge ended follower. You can do it maybe like this. So wedge ended follower. That will be my follower. And then they said the height of the wedge ended follower. The height is 68 millimeters. So the height is 68 millimeters. 68 millimeters. That will be the height, which is 68 millimeters. 68 millimeters. So we have written then our cam follower. Now we go to the motion now. As you go to the motion, it tells us now that from this given information, draw the displacement graph. the displacement graph with the horizontal scale of 7 millimeters equals to 30 degrees, and the vertical scale of 1 is to 1. Vertical 1 is to 1, and then horizontal 7 millimeters equals to 30 degrees. 7 millimeters is equals to 30 degrees. Now it will start from the bottom, from the minimum distance. That is our minimum distance that the follower will start working on. But now I'm wary of starting to draw my cam profile here, my cam displacement diagram. I would prefer first to start looking at the movement, the height, the total height, so that I'm able to draw the outside circle. Because I just want, just for space purposes. Remember I said it will move 40 millimeters, but over the first 120 rises to 40 millimeters. There's 40 millimeters rise. The follower then rises with uniform motion to a total height, which means the whole height that it will rise from here. It will rise to a total height of 65 millimeters. The follower then falls. From 65, now it's going backwards. It falls over the next with uniform motion. The follower returns to its original position. It falls and returns, which simply means the total height that it will rise, it is 65 millimeters. Now, let me draw my 65 millimeters. The total height that I've established is that it will rise up to 65 millimeters up to here. That is my 65 millimeters. Now, from here, the minimum distance to there. So from the center then, I will take it to the total height where it will rise. Then I will make my circle. Very faintly, it's a construction. Mine is a little bit darker, just for that, for you, for your own benefit, guys. And then, so now I know where I can start drawing my profile. I know my 65, it goes up until there, very faintly, and then I may start somewhere outside there. I know here I have the total. Okay, I can put this one up here. I will have a difficulty in moving my camera. We'll see how we can finish that one there. That is the total height. Now they said also here, they indicated to us that 7 millimeters equals to 30 degrees. 7 millimeters equals to 30 degrees. That is our displacement graph. Our displacement graph to indicate that, indicate here nicely, displacement graph, placement graph. Uh, 7 millimeters. Okay, I'll do that just to show it nicely. They say 7 millimeters, 7 millimeters, 7 meters equals to 30 degrees. Now I will take 7 millimeters. I'll mark 7 millimeters. 7 millimeters. There's 7 millimeters. To be 12 equal spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Right? Let's hope you can see. There we are. Now, very faintly, all my lines. You don't want to spend too much time, but this is a little bit longer question. You might need to complete it in 30 minutes maximum, 30 to 40 minutes. If you are as slow as I am, 40 minutes. As long as you understand it, it's not a difficult question, but I've chosen one that is a little bit a combination of different types of these cams, different type of movement of the cams. Now, this is the 0 degrees, 30, 60, 90, 90, 120, 150, 180, so on, 180, 210, 240, 270, 270, 333, 60. Aha, there we are. Now, in the meantime, because it's going to they tell us, they say the plate cam rotates at a constant velocity in a clockwise direction following the motion of the wedge-ended follower, which reciprocates along vertical center line that passes through the center of the cam shaft. So I will want to divide this plate here into 12 equal parts. That represents 30, 60 degrees from 0. We'll do that. Do that. And that. Now I have divided it into 12 equal parts. Okay, this one I extend this 180 degree line. Now they say it rotates clockwise. These are marks, guys. You show the direction it rotates, that direction. Clockwise, it goes that way. There is a direction, it rotates clockwise. If it rotates clockwise, this will be 0 and it starts here, 0 and 360. So this is the cam that rotates. This follower stands here. So as it comes, this plate will come from the left hand. So it will be from here to 1 up to 30. So my 30 degrees will be on this side. Because we start counting from it coming this way, the plate, it will be 1, 2, up to 30. And then here is 90 degrees on that side there, 90, 180 at the bottom, 180, 270, 360, and so on and so forth. Now let's follow the motion now. What does it say? It says now, 1, Over the first 120 degrees, the follower rises to a height of 40 millimeters with simple harmonic motion. Over the first 120. Let's look. 90, 120. 120 is here. Over the first 120. 120 is here. It rises by 40 millimeters. 90 by 40. It rises by 40 millimeters. This will be the rise. It rises by 40 millimeters. I will do this. Something I want to show you here. Since it rises by 40, I will look at the center of 40 there, that 40 which is 20. I'll look at the center of 40 because it is simple harmonic. This is what we do when it is simple harmonic. That is the center of a simple harmonic movement. Let me check whether my center is correct. My measurement, it must be 20. Right, from my center, I will draw that arc there, over there, and I will divide it. I will divide it. Look at what I've done. Divided that arc. Because it's simple harmonic, you will see, don't worry, it goes up to there, and there. So look, this is where the trick lies. It is 1, 2, 3, 4, 5, 6. Even that way, I must go 1, 2, 3, 4. Now it is 4. It is no longer 6. That's where the challenge might be. So I want you to understand this very, very carefully. Since this is divided into 6, we must divide from this distance here. Now we're looking at this distance from here to there into 6 equal parts, not 4, so that our lines could correspond. But we know this one is halfway line. That here it is halfway line, which means we want to have 3 equal spacing here and on the other side 3 equal spacing here. So you would want to, at 60 degrees, you would want to divide this line into 3 equal parts, and then can do it by a ruler if you want to save time. You say this, when I measure this, it gives me 15. If it gives me 15, yes, it gives me 15 here. So half of 15, 15 divided by 3. 15 divided by 3, it will be 5, 10, 15. I will use these 2 lines. They have divided this half into 3. Even that side, I will no longer consider these ones that are there. For my simple harmonic movement, it is 5, 10, 15. I will also consider those. I will mark them by a pen, a red pen for you, so that you understand what I am trying to say to you. I am saying half of this. If these lines were 6, also it will be easier. But now they are 4. It's 120 up to 120. Now it's up to you to get into the half of this distance from 0 to 120. Half of here is that distance. Half of it is there. Half of it you divide it into 3, and the other half you divide it into 3. That's what I've just done. Here is my line of division. It goes up to here, that's all. It was just it goes up until here. It's just to harmonize my movement. This one, they all goes up to here. It goes up to there. I hope you have understood what I've just said. So it is this one from here. If it rises a simple harmonic, it will be 1, 2, 3, and then it will be 1, and then the second one will be here 2, 3. That will be my harmonic movement. It will be like that. You want to have a steady hand when you're doing this stuff, guys. Now my tatas. There we have our first simple harmonic movement. It's harmonic, it's not constant velocity, that is straight up to 120. Now we go on. When we go on, what does it say? It says the follower then rises with uniform motion to a total height of 65. Uniform motion. That's uniform velocity. Total of 60 over the next 60. Over the next 60 degrees. From here, 60 degrees. Next 60 degrees is 30, 60. It rises to 65. Already that 65 we have measured it. 30, 60. That 65 is here. Remember, it moves. We said it is going to move that whole height. That will be the maximum height. And then that one, because it is uniform. It is uniform. It goes straight. You don't have to divide anything. It is uniform. It rolls up until there. And coming back again. Reading is Ngamla, the English part. Now the follower then falls 25 millimeters. It's going down now. It falls 25 millimeters over the next 60 degrees with uniform motion. Uniform. It falls with uniform over the next 60. When we say next 60, 30, 60 up until here. But it falls by how much? The follower then falls 25 millimeters. Let's check what is it? Over the next 30, 60 degrees. But it falls by 25 millimeters. We measure that 25 millimeters. Let's see, you can see over there we are, 25 millimeters. It falls there up to here. Then you join, because it is uniform, constant, it's uniform. By over the next 60, 30, 60, falls back. And then lastly, we are here. Now we are here. Follower falls over the next 60 with uniform motion. Then lastly, the follower returns, goes back to its original position over the last 120 with uniform acceleration and retardation. When it's acceleration and retardation, falls back to original. Originally, as we know, it was here at 0. It went up. It falls with uniform velocity, with uniform motion. Now, but it returns to its original position. Original position is here at the bottom here. But with what? With uniform acceleration and retardation. How do we draw that? Acceleration and retardation. It falls up to here. It falls with acceleration and retardation. So up to here it will fall. Then we will take also this distance. And then if you look at it here, half of that is also 20. So as you can see, what we are here, that will be my center. Half of it is also 20. Even this one here, we're going to divide it into 6. When we divide it into 6, and here is the center. I know that one is the center. So I will divide this part into 3 and that part into 3. Hopefully it's also 15. Let us check. If it's 15, it's much easier. If it's not 15, you divide it accordingly. Yes, it is 15, and we will use 5, 10, now 15, 20, 25, 30. Yes, it will be like that. There we are. Here is the new lines that we have created to divide that one. You can differentiate with those lines because this one goes up until there. The ones that we have created, 5, 10, 15, 20, 25, 25, and 30. 25 and 30. So that's how it is going to fall. It falls with uniform acceleration and retardation. Now what do we do then? From the center, from this center here, we are going to divide this part into 3 parts and that one into 3 parts also. Let's do that. Yeah, that is our center into 3 parts. It is 20, it's 40. So if we divide 20 into 3 equal parts, you may like to do this. You like to do this. You know the parallel lines. When you're doing parallel lines, you like to do this on the other side there. Like to do this, but I will only do the first 3. I'll do the 3 because the other, it disappears from my screen. 1, 2, 3. Those are the 3 lines, and then I do parallel lines. I take the first one and remove my T-square there, take my first line. I'm using now set squares to draw parallel lines, create 10 stuff as the learners were doing, create 10. The last point, I align it there and then I slide whilst keeping this one firm. Then I will also slide there. I've divided this into 3 equal parts. So now the only thing I can do now, right now, I can just transfer this thing here to the other side. 1. You've seen how I've done it. 2. They are all 3. And then this is what I'm gonna do. This is what I'm gonna do. Stay with me here. I need you to stay with me here. With that one. And this will be our first line. This will be our first line. It will start here. We'll go up here. 1, 2. I'll use another pen that you are able to see. Here is my 5. Okay, before I use a pen, I will do this. From here is the center. This one from the corner there, I will take it to the center. That one to the center. That one to the center. Hey, where there? That one to the center. That one will correspond with that one to the center. And then this one from here, I will take it. Yes. Take this one to this center here. That one to that center there. Here is my center. This is my center. Here is the line that I take. If a very constructed line, very faint line here, it goes there. Then from there, I'll take it to the center. From that corner, I'll take it to the first line out of my 3 divisions, equal division. That one and that one. Even from this one on this side, I will take it to the center, first line, second line, and the third line. Are you with me? Now here is the first one. The first line is there. Sorry, the first line, it is there. The second 5, 10, the second line here, this one, the second line joins there. And then the third line, we are all here. From this side, my 5 is here, my half, my 3 divisions. Here is the center. The first line of division was here. It's 1. The second line of division is, wait a minute, let me not confuse myself. This is the first one. The second one is this one. Second one. The third one is that one. Again, that one, it will correspond with my division here, the first division. First 5, 10, 15. The second 10 is here with that one. The third one is there. Even that side, the first 5 is here, second 5 is here, third 5 is here. So I will join that. You need a steady hand. There we are. 1, 2, 3, up to that corner. And there we have our uniform acceleration and retardation. It goes back to its original position. Now we want to transfer that. We've done our graph right now. We're transferring it to our profile. This is displacement graph. Now we are creating our cam profile. Now there we go. 0 degrees is here. It's there. Fine. 30 degrees. Okay, now I think I need to write it now. 30, so that you don't get confused. 30, that is 60 degrees. 90 degrees is this one. 120, 150, 180, 210, 240, 270, and then a 300, 330, 330, and then 360. Voila, 30 is here. There is my 30 degrees. 30 is here. 30, 60 degrees is there. 90 degrees. Where is my 90? My 90 degrees is here. I've taken 30, 60, 90 degrees. Still it. That I transfer it to 30. Transfer it very faintly to 60. Transfer it to 90. To 90. 90 is here. Transfer it to 90 degrees. Now, from 90, 120. 120 is there. I transfer my 120. 120. 120, 150 is there. 150. 180 is right at the top there. Now it is 1. This one is 120. 120 is here. Transfer it to 120, and then that one, it's 150. I take it to 150. The last one is 180. 180 is right there at the bottom. There is 180. This one, 180 there at the bottom. 180. There we are. We're at 180. 180 here, there, and 30 is there. So now this one I don't want to transfer from that side. It's nearer for me to transfer from this side, from 210. Now 210 is there. Where is my 210? I take it immediately because now I have many lines. I don't want to get confused. There is my 210, and then 240 is there. There is my 240. 240 is here, and then 270. Where is my 270? There is my 270 is there. There is my 270 here. Yeah. Oh yes, I see. There is my 270. This one is my 270. Let me take my 270. Did I? Wait a minute. Where is? I'm lost now. 270 is there. There is my 270. See, that is why I was rushing to do this stuff, so that 270, 300 is here at the center. There is my 300 at the center. 300 is here. 330 is here. Where is 330? 330 is here. It's here. 330 is here. There is my 330 here. 330 is here. And then 360 is back there. Now my profile. My profile, you need to have a steady hand when you're drawing your profile. From here it will be your 30 or 60. Where is my 60? It was there. I just don't, my 60, I don't remember which one now was my 60. It's there, just to verify. Sorry, here is my 60. Where? There is my 60. It's my 60 there. Now from here you go to 30, go to 60. Hand needs to be steady. Oh, I did not mark 150. 150. Forgot 150. Yeah, where? 150 is that one. Where is 150? There is 150. Hey, 150 is there. Check. Yeah, there is 150. 150. I've marked it wrong. My 150, I've marked it here at 180. 150 is there, 180 is here, 150 is there. Check your stuff so that you don't make mistakes. Now we want to just make a very nice curve. We are looking at 3 points that join. You're looking 1, 2, 3. You know there that you're going to join it nicely, as it will come up also on that side. Free hand, Baba. if you have time, you can use your whatever, but it's not necessary. Do it freehand. We do it freehand. Freehand. Then you will have something like that. So this is how your profile. This is your cam profile. The design of your profile informed by your displacement graph. 1 millimeter equals to 1 millimeter on that side. You will have a cam that looks like that. Its profile will be like that. That will give us this motion as it rotates. Guys, I hope this one is almost a summary of cams. Yeah. I hope you have enjoyed it. Thank you.